Good day, my dear. Today's topic is producer theory. This lesson is about the producers. So you have to think about the firms and you forget about the consumption side. We are focusing on the production side. The most important thing when it comes to the producers is the cost of production. You might want to write that down, it's quite important. So the focus of all the production side is the cost. All right. So there is this simple formula for profit. Profit is total revenue minus total cost. All right. And the symbol that we use for profit is pi. Total revenue is TR and total cost is TC. So if you see those abbreviations, that's what they represent. Total revenue is what the firm receives for the sale of its output. Right? It's the income, it's the earnings. Total cost is the market value of the firm's inputs and sacrifices. So when we talk about inputs, you should remember the example of the bakery, right? Remember that the bakery has some inputs like flour and dough and whatever, and has some output. So total cost focuses on the production side, which is the costs. Now, economic cost, this sacrifice should remind you of that idea of opportunity cost that you've seen before. So economic cost is the same as opportunity cost, and opportunity cost has two elements to it. One is explicit costs, which are input costs that require an outlay of money. Outlay of money is when you actually have to pay something, when there's a transaction for it. So those are the costs that we are familiar with. The other one is implicit costs. These are a little bit hidden. So these are costs that don't require an outlay of money. This is exactly the idea of a sacrifice. So there's a nice analogy of an iceberg. So think of the tip of the iceberg, which is outside and everybody sees. That's the explicit cost, and the rest of it, which is inside, is the implicit cost. We have to take both of them into account. Now, contrast that with accounting. In accounting, the only thing that counts is the explicit cost. Only if there is a transaction for it, so there is some recording of it. So one example of economic cost is opportunity cost of financial capital, which is the foregone interest that could have been earned if the firm had invested the capital. All right, you have to include that in the cost accounts. So for instance, for a new company, a lot of times what they have to do is they have to invest huge sums of money. Well, they could have put that in the bank, for instance, and earned interest on it. The foregone interest is also a part of the cost of that production. Time to pause. So we just said that in economics, the cost includes both explicit and implicit. In accounting, cost includes only explicit. Now, given that, think of profit. In which case is there going to be a higher profit, in economics or in accounting? Well, if the cost is higher in economics, then the profit is going to be lower. So here's a very useful picture which reflects this difference between economic and accounting costs. So if you notice on the left-hand side, we have the economic view where there are three divisions. Basically, you have implicit costs, you have explicit costs, and all of that is included as total opportunity cost. So the leftover, the economic profit, is smaller. All right, now this is quite useful later on. You're going to see that sometimes we talk about zero economic profit. Zero economic profit is not such a bad idea, because zero economic profit means positive accounting profit. Alright, we're going to talk about the production function, which shows the relationship between the quantity of inputs and the quantity of output. Alright, so how the inputs are converted into output. It's called the total product, TP, and that's the total output produced. Alright, so for instance, consider a firm that makes sweaters using labor and knitting machines. Then its production function in general form would look like TP is a function of quantity of labor and quantity of machines. This is the functional notation. It simply means dependence. So what it means is that what you have on the left-hand side, the TP, depends on the quantity of labor and the quantity of machines. In other words, in the number of workers and the number of machines that they have. We have average product, which is simply TP over L. So how much output each worker makes on average. So this is the productivity of the workers on average. And we have marginal product, which is the change in output as a result of an extra unit of input. So for instance, you have marginal product of labor, which is how much one additional worker will add to the output. So you've seen this idea of marginal before, and this is a very central concept in economics. So labor being the most important input gives us this idea of marginal product of labor, right? So if you hire one more worker, how much will your output increase? That's marginal product of labor. All right, so the formula for that is change in output over change in labor, and this delta, this is a capital D in Greek, this just means change. Okay, so whenever you see this delta, it means the second value minus the first value. So delta L means L2 minus L1. So that's a useful formula. You might want to box it. And I just want to emphasize one more time this idea of marginal product of labor. All right, if you have one more worker, how much will your output increase? Pause here and write down. There's this law of diminishing marginal product which says that the marginal product of an input falls as more of it is used. Now remember, marginal product of input is when you add more workers, how much does your output increase for each worker? Okay, and the reason for that is that you have some fixed inputs. All right, like a limited space or fixed number of machines and computers. So let's say you have a limited office space and you keep adding more and more workers. All right, so they're gonna just be crammed there and they're like, oh no, what's going on here? Yeah, so that only happens in the short run when the firm does not have the chance to expand its facilities. So, and we're going to look at the short run later, but the definition of short run is exactly the condition where you can't expand. Okay, so let's look at an example. Let's say you start mowing the lawn with your only lawnmower. So you have only one lawnmower and you start mowing the lawn. And at some point your brother comes along and says, hey, I want to help, I want to help. So you're like, okay, fine. And he can help, he can save you some time. So when you're resting, he can do the work, right? But then the girl next door comes in and says, I want to help too, I want to help too. And then you're like, okay, fine, you can help too. And she can contribute a little bit too. But imagine more and more people coming in. If you have only one lawnmower, I mean, how much can they contribute, right? So if more and more people join you, each new person will add less to your output. So it's going to be less helpful since you have only one lawnmower. All right. So that's the idea. It's not that your productivity goes down. It's just that each of them is going to be less helpful than the last one. Okay. So write down, and if you want to try it, try to draw a lawnmower for yourself. It helps you retain the material. Wow, that was cool. Let's look at some cost types. We have fixed costs, FC, which are costs that don't vary with the quantity of output. So for instance, factory or warehouse, you have to pay for its rent or maintenance no matter how much you produce. Okay, so even if you shut down, you still have some bills to pay for your factory building. So those bills that you pay, those would be part of your fixed cost. The opposite of fixed cost is variable cost, and those are costs that vary with the quantity of output. So the more you produce, the more you have to pay for them. These are running costs or operating costs. You might want to write those words down, by the way. Variable cost is the same as running cost. It's the same as operating cost. So for instance, you have wage for workers, you have oil. If you have a lawnmower, you have to put oil in it. You have flour for bread. So we have anything that you need to, anything that varies basically with the quantity of output. So wage is quite important here because in economics, labor is a very main input. All right, so that has special place in economics. So here's a good picture that covers it all. So let's say you're making lemonades. The machine, the mixer, or whatever that you have, the stand, the rent, those are your fixed costs, and the lemons or the new workers that you hire would be your variable costs. So total cost is simply fixed cost plus variable cost. You add them up. Average cost is when you divide the cost by the total quantity of output. Okay, so whenever you have the average of anything, you just take the total and you divide it by the quantity. So for instance, average total cost, ATC, is total cost divided by quantity. Average fixed cost, AFC, is fixed cost divided by quantity, and average variable cost is variable cost divided by quantity. Which means if you do the math, you're going to get average total cost equals average fixed cost plus average variable cost. All right, so pause here, write down your notes, and write down the formulas. Okay, some more terminology. There is this idea of efficient scale, which is also called capacity, and that's the level of output where your average total cost, ATC's average total cost, is the lowest. So on average, you're minimizing your total cost. Marginal cost is the increase in total cost due to an extra unit of output, right? So if you make one more unit, how much will your total cost increase? That's marginal. It's how much does it cost to produce one more sweater, for instance. Okay, so remember, marginal is always about one additional, so you're just adding one more brick to your building. There is this idea of short run versus long run. Short run is when the quantity of some inputs is fixed and the quantity of some is variable. Right? So certain things are fixed, other things are variable. Wow, that's so cool. So the firm's short run decision is how to use its fixed plant and equipment and how many workers to hire given its fixed resources. So usually the fixed stuff are things like plant and equipment, and the variable stuff is workers, right? So you have to decide how many workers. You can't really change the fixed stuff, you're stuck with it in the short run, but you can change your workers, right? So the main thing in the short run for the firm to do is to decide how many workers to hire. The long run is a situation where everything is flexible, so all of the inputs can be varied. Just to remind you, this idea of inputs are the same as resources. Remember land, labor, capital, right? So this is the same thing as resources, as opposed to output, which is the end product. So inputs, resources, factors of production, those are all synonymous. So the firm's long-run decision is how to expand its capacity, right? Or how to build more factories, how much you want to develop yourself and buy new buildings and so forth. Okay, pause here. Increasing returns to scale, which is also called economies of scale. That's when average total cost falls as more output is produced. So for instance, if all inputs are increased by 10%, your output will rise by more than 10%. Okay, so imagine you have a flower or a plant or whatever, and if you invest in terms of inputs, in terms of the time and the water and the sunshine and whatever, if all of those inputs increase by 10%, the amount of growth is going to be more than 10%. If that's the situation that you have, then that's called increasing returns to scale. It means that overall your costs are decreasing on average. And this is usually because of specialization or division of labor. So specialization is when you allocate different workers to different departments and you say, okay, you focus on this part and you focus on this other part. And this way each of them can be more productive, right? So that can be actually useful. So as production rises, it becomes profitable to use cost minimizing equipment. And these equipment, think of, fancy machinery and robotics and whatever, these are usually too expensive for smaller plants, right? So small companies can't afford them, but at some point they can as they expand. They're usually high initial costs, but once you take care of those setup costs, then you can easily increase your output at very low marginal cost because of excess capacity. Here's a simple example. Let's think of an airplane. It's very expensive to buy an airplane, yeah? But once you incur that initial cost, you can easily add more passengers. It doesn't cost much to add one more seat and have more passengers. So as long as you haven't filled the whole airplane, it's easy to add more and more passengers, right? And that's why when you divide the total cost by the number of passengers, your average cost is going to decrease. So total cost is divided over a larger output, and that's why you're going to get a lower average. Okay. So it's profitable to increase production whenever you have increasing returns to scale. Why is it profitable? Because the revenue is rising faster than the costs. Okay, so overall your profit is going to increase. All right, there were some cool effects in that slide. So take some notes on this. The opposite of that is decreasing returns to scale, which is called diseconomies of scale. And that's exactly the opposite. So it's when the average total cost rises as more output is produced. So for instance, if all inputs are increased by 10%, your output will rise by less than 10%. So you're increasing the inputs a lot, but the output doesn't respond much, which effectively means that you have increasing costs. This happens when you have a large company, a very large company, and at some point it becomes difficult to plan, organize, and monitor, right? So you're like, oh no, what's going on here? I'm so confused, right? So a lot of times what happens is that, maybe workers start distracting each other, right? So, or in other words, there are multiple layers of middle managers and supervisors, and sometimes they're just motivated by their own interests instead of the company's interests. So the firm stops being profitable. It has reached its capacity. There's no point in expanding the firm any further. So it's too large to manage and remain efficient. It's unprofitable to increase production. Why? Because it's so cool. Because the costs would rise more than the revenue. All right, so it's better to actually reduce production whenever you have decreasing returns to scale. Between increasing and decreasing returns to scale is a middle ground, which is called constant returns to scale. And that's when average total cost is constant as more output is produced. So if all inputs are increased by 10%, output will rise by exactly 10%. That means that your average total cost is at the minimum, and the firm would like to be at this point. So that's kind of like bullseye. All right, so that's when you're maximizing the profit in the long run. A couple more concepts. There is a principle of substitution. When one input becomes relatively more expensive, firms will change their method of production to use more of a cheaper input and less of the more expensive one. So this is kind of like if labor becomes expensive, firms will replace the workers with machines, right? And this is what all of us do. I mean, if you buy something and you realize that the price of that has gone up, you're going to try to buy some substitute, right? You're going to switch away, right? So that's kind of intuitive. And cost minimization is that a firm would want to produce any level of output at the lowest possible cost. So whatever they want to produce, they would like to minimize their costs. And that's kind of obvious again, because they want to maximize their profit. So cost minimization is an implication of profit maximization. Pause here. Talking about cost minimization, there is this concept of isoquant. And that's the different combinations of inputs that produce the same level of output. All right. So first of all, let's clarify something. When we talk about inputs, another name for it is factors of production. And that's also the same as resources. So you've seen the resources like land, labor, capital, entrepreneurship, right? Those are inputs. If you remember, we had an example of bakery where we had the inputs of a bakery like dough and the output being bread. So we are talking about the process whereby inputs are converted into output. All right. So let's look at an example. Let's say a firm has two inputs, capital and labor. You can think of capital as machinery or computers, for instance, and labor is workers, right? So the symbol for capital is K, it's kind of like German, and the symbol for labor is L. So those are the two things that they use, right? So you can have, I don't know, knitting machines or carpenters or whatever it is. And let's say to produce 4 units of output, you need 4 units of capital and 4 units of labor, all right? Now, what happens if you don't have 4 units of capital? If you still want to maintain your 4 units of output, let's say this is our assumption, if you still want to have that much output and you don't have 4 units of capital, then you need to increase your workers. Yeah, you have to replace one input with the other. So let's say if you reduce your capital to 3, then you should increase labor, right? You should increase labor to what? Well, if you have one less capital, it's likely that you need more than one labor, because then you don't have as many machines for the workers to work on, right? So let's say you need to increase labor to 6 units. All right, so by 2 units you have to increase it. If you reduce capital even more, if you have even less computers or less machines, then you need even more workers, right? So if you reduce your capital to 2, then you should increase labor even more, and still at even a higher rate, you have to replace them. So in this case, let's say you have to, oh, that's kind of cool, you have to replace 4 more workers so that they can give the same amount of output. All right, so all of this is assuming that you want to have the same level of output, right? So the idea is that at some point the workers are like, oh no, I can't keep up with this anymore, because, you know, how much can a worker replace the machine, right? There's a limit to that. And the technical term for this is diminishing marginal rate of technical substitution. You've seen this idea of diminishing rate before, right? So diminishing marginal rate is that each additional worker cannot be as effective as the previous one. And you've seen this idea before. So pause here. So let's draw the example that we just saw. And we're going to have labor and capital on the 2 axes. These are our 2 inputs. And we're going to place the first point that we had, which was 4 and 4. We had 4 workers and 4 machines, which gave us 4 units of output. So that's point A. The other option was when our number of capital reduced to 3, then we needed 2 more workers, right? So we had another point there. That also gives us 4 units of output. And then the other point was if you have even 1 less machines, then we need even more workers. So in our example, we had 10. So those are the 3 points that we were given in the last slide. We just placed them on the grid. And you can imagine other points. If we have more machines, then we need less workers, right? So you can kind of make a symmetrical shape and then connect the points. All right. This is very similar to what you saw with the indifference curve. It's not exactly the same, but it's similar. The shape is the same, but the concepts are very similar. Okay, so it helps to review your consumer theory material here. So you can extend that, and we're going to call this isoquant curve 1. Now imagine another point. What happens if we want to produce more things? Well, if you want to produce more output, you need more input. Duh. Yeah, I mean, if you want to make more bread, you need more flour. Right, so that would be a point, let's say A prime, where you have 6 workers and 6 machines, and that gives you more output. And you can draw another parallel curve to that. This is curvy, by the way, because of the diminishing rate, and that corresponds to a higher level of production. So the moral of the story is higher isoquant curve means higher output. It means more production. And because you're producing more things, then you need more inputs. All right, so that's the idea for now. Really, it's about input and output, right? This is a funny picture. The put is just for the fun of it. But input, yeah. If you have a chicken or a rooster or whatever, they feed on certain things like, I don't know, worms or insects or grain or whatever, and that's their input. Okay. The egg that they produce, if you have an egg farm, for instance, that would be the output, right? If you want to have bigger eggs, you need to feed them more, right? So that's the idea. Pause here, do a nice graph for yourself. If you have graph paper, it helps. If not, use a ruler and make a neat job. When we talked about the indifference curve, we also had something called the budget line. Now, something similar to the budget line in the case of producers is called isocost. An isocost shows the different combinations of inputs that add up to the same total cost, right? So let's look at an example. Let's say our company, which hires capital and labor, has $120 worth of budget for these 2 items, and the cost of capital is $10. By the way, the cost of capital is called interest, and the cost of labor is called wage. Right? So you've seen those terms before. So the wage rate is 15 per worker or per hour, and the cost of capital is $10 per machine, or again per hour. So we're going to draw, and the way to draw it is very similar to the budget line. If you remember, when you have a fixed level of budget, what you do is you take your total and you divide it by the unit cost, right? So in this case, if you have $120 and if you want to use it only for capital, how much capital can you afford? Well, 120 over 10 would be 12, right? So you get a point there at 12 where you're not getting any labor. If you only want to get labor, then you divide 120 by 15, right? And you would get 8 there, so you get another point. And you can connect these 2 points, and that's going to give you your isocost curve, right? So TC stands for total cost. The total cost here is 120. Now, what if your total cost drops to 60? Now, if you have less budget available, well, you can afford less units of inputs. So again, what you do is you take your 60 and you divide it by the 10 and the 15. So you get 6 units of capital is the maximum number of machines you can buy, and the maximum number of workers you can hire is 4. All right, so you connect those and you get your second isocost curve. All right, so it shrinks, it goes inward, it gives you less availability. Wow, that's kind of cool. So cost minimization is when you try to be as lowest as possible. So the firm wants to minimize their cost, so they would like to be on TC2 if possible, rather than TC1. Pause here again, do another graph for this. Try to do a wide and large one so that it's not messy. Time to put things together. So the producer's optimal choice is to minimize cost given their output target. So they would like to minimize their cost, and we want to show this graphically based on what we saw. Again, this is very similar to the budget line and indifference curve that you saw before, so that can be a point of reference for you. It's not exactly the same though, so we're going to see that there's a little bit of difference here. So first of all, let's see what is their target. So their output target is IQ1 here. That could be, I don't know, 4 units, 6 units, or whatever. And let's imagine 2 different isocost curves. Remember, the lower the cost curve, the lower the cost to the firm. So the firm would like to be on TC2, right? That's desirable, but they can't make it, right? Why? Because there is no intersection between the total cost 2 curve and the IQ1 curve, right? So that's not achievable. They need to hire more workers, right? So TC1 is achievable, but that's not the lowest cost. They can do better than that, right? So again, you would have to draw another line which barely touches the IQ curve, and that in this case is going to be your TC3. That's going to be your optimal choice. So that's where the isocost is tangent to IQ, and tangent means barely touching. So the principles are the same that you've seen before. You have the skills to do this. You just draw a tangent line and you find the point of their tangency. That's going to be the optimal point. All right, so in this case, they're hiring, I don't know, 4.5 units of capital and 3 units of labor. So the moral of all this mess is that you want to hire workers and machines. How much of each do you hire? Well, that depends partly on the cost of each and also on your ability to make output, right? That's why you have to put these things together and you try to target for the lowest possible cost. So pause here and write down your notes and do a nice graph.